Dear students, in today's class let us discuss about the another semiconductor diode called Zener diode. As like semiconductor diode, the Zener diode will also have a two terminal, that is anode and cathode, and it is also a single junction device. The difference between semiconductor diode and Zener diode is the semiconductor diode can conduct only in one direction, so that is from anode to cathode. But in case of Zener diode, it can conduct current in both the directions. That means it can conduct the current from anode to cathode as well as cathode to anode. The Zener diode is a special type of PN junction diode. Why it is called a special type means, if we connect this device in a reverse bias category, it can give a constant voltage, so that this device can act as a voltage regulator during reverse bias mode, and the reverse breakdown voltage is adjusted precise between the range of 3 volt to 200 volt. And here you can see the symbolic difference between semiconductor diode as well as Zener diode. The cathode shape is alone changed. In semiconductor diode, the cathode is like a straight line, and in Zener diode, the cathode is like Z shape. So this is the symbolic difference between semiconductor diode and Zener diode. If we goes into the characteristics or the working principle of the Zener diode, you can analyze with two modes of operation. That means you can analyze the Zener diode with two modes. One is forward bias and another one is reverse bias. So before analyzing this category, we must know what is forward bias and what is reverse bias. So the forward bias is nothing but if the positive terminal of the source is connected to the anode and negative terminal of the source is connected to the cathode, then the device is said to be, it is connected in forward bias mode. And reverse bias. So the reverse bias category is that if the positive terminal of the battery or source is connected to the cathode of the device and negative terminal of the battery is connected to the anode of the device, then we can say the device is connected in reverse bias mode. So during forward bias mode, the current conduction will be there. So once the depletion region is depleted, the diode will start conducting the current. You can see the VA characteristics of Zener diode here. So up to 0 point, that is midpoint to the cut-in voltage, there is no current. Here we have taken forward voltage in x-axis and forward current in y-axis. The same way we have taken reverse current in minus y-axis and reverse voltage in minus x-axis. And from 0 to cut-in voltage, there is no current. It says that if you are giving a supply voltage to the device, once the depletion region gets depleted, then only the diode will start conducting the current. That means, what is depletion region? That means, depletion region means due to immobile ions present across the junction, it may have a voltage. That voltage is called barrier voltage. So that barrier voltage is due to immobile ions present across the junction. So if the supply voltage is greater than that barrier voltage, then only the diode will start conducting the current. So after cut-in voltage only, the diode will start conducting the current. If you compare the positive, that is, if we compare the forward characteristics of semiconductor diode and Zener diode, both are same. And if you go with the reverse category, In semiconductor diode, only the reverse leakage current I0 will be there. But here from 0 to VZ, reverse leakage current is there. But after the breakdown voltage, the current starts increasing, but the voltage remains same. That means whatever may be the input voltage, the reverse breakdown voltage range of that particular diode will be always same after the breakdown voltage. For example, if I take 5.1 volt Zener diode for analyzing the VA characteristics purpose, the forward characteristics will be same. That is, after cut-in voltage, the diode will start conducting the current. But in reverse category, once the reverse voltage reaches 5.1, whatever may be the input voltage, I can get 5.1 voltage as output. That means after breakdown voltage, the voltage of the Zener diode will be same, whatever may be the input voltage. If the input voltage is 30, I can get only 5.1 voltage as the output voltage, because I have taken 5.1 voltage Zener diode. The breakdown range of that Zener diode is 5.1 only, so that I can get only 5.1 voltage as output. So that we can say the Zener diode can act as a voltage regulator during a reverse bias category. And if we compare PN junction diode and Zener diode, the definition comparison is that PN junction diode conducts current only in one direction, that is forward direction, but Zener diode